All right, guys, 11.2. We're going to be finding area of circles and sectors today. So this lesson, I think, is very similar to the last one. All right, when we found circumference and arc length. So our goals today are going to use the formula of the area of a circle. We're going to find areas of sectors and then use area of sectors. So the area for a circle is area equals pi r squared. Okay, there will be some formulas, okay, in this chapter, quite a few of them. Depending, we'll see how it works out, how many there are. I may give some to you on the test. I will not give circumference or area to you. Those are just those are ones that we have to know. Circumference and area of a circle are basic. They'll be used throughout math classes. We just need to know those, okay? Now, how do you differentiate between circumference and area as far as the formula is concerned? Well, when you find area, our units are always squared, aren't they? Square inches, square feet, square whatever. And so the area or the formula for the area of a circle has a squared in it. That's how I make the connection. So again, like we did on the last lesson, we're going to use this formula and plug in what we know, solve for what we don't. So if I look at the first one, it says find the area of the circle if the radius is 2.5. So area is going to equal pi times my radius, which is 2.5, squared. All right, so if I take 2.5 and I square that, that gets me 6.25. So 6.25 pi. Again, that is our exact answer. All right, so if the computer or on a quiz or a test it asks, hey, find the exact area. Well, here it is. It's this centimeters squared. Note that when we have our label with area, we're no longer talking about a linear measure. It is an area that, or a measure that covers space, like this floor, so our label needs to be squared. Okay, if it doesn't say that, well then we can give a decimal approximation, which is going to be 6.5 times pi. And again, pi is our second caret key on our calculator, so 19.63 centimeters squared. I do not believe any on our homework say exact today. Okay? But again, if it says that exact, or it says, hey, leave your answer in terms of pi. All right, I think there's an answer on our homework that said that. Leave your answer in terms of pi. That means, hey, keep a pi in your answer. Don't put it as a decimal. Leave pi in your answer, and that's okay. All right, the second one says find the diameter of a circle when the area is 113.1. So I'm going to use my formula again. Area equals pi r squared. Plug in what we know. In this case, where we know the area. So 113.1 equals pi r squared. Well, some people might say, well, Mr. Cole, we're trying to find the diameter here. I said, I know that, but we don't have an equation for the area of a circle that uses diameter. So all we're going to have to do is just find the radius and then double it in the end. Okay? So how am I going to solve for r here?
Could you divide by pi?
What's sitting nice and loud for everyone?
Divide by pi.
Yeah, we want to get rid of pi. And some people say, oh, I want to square root. Well, we want to get rid of everything else before we square root. So let's divide both sides by pi. Okay, and so those will cancel on the right side. So here I get r squared equals, what do we get there? 36.000. We'll just call that 36. Okay, and now I can square root both sides. And so our radius here is going to equal 6. Questions on that? Did I answer the question? No. Oh, no, I didn't. It says find the diameter. Well, we better double that. If the radius is 6, the diameter needs to be 12. Guys, one thing I'll say, and this, I'm kind of getting picky here, but it was 36.00, right?
00.
Okay, so 3 zeros. I just want to let you know, let's say our radius, after we square rooted it, our radius was 6.34. Okay, well, 3,4, let's say it was 344. I'm kind of being picky, but if I know I need to find the diameter, let's double the exact answer. So let's not round my radius, but double my exact radius, because that could throw off our diameter by maybe a tenth or a hundredth or something. Again, I'm getting pretty picky there, but I think that's always a good idea to keep in mind. All right, the next one. It says find the area of a circle if the diameter is 13. So what's our formula if we have the diameter? Yeah, we don't have one, do we? We don't have a formula for the diameter. We only have one for the radius. So if I'm given the diameter, I better cut that in half. So half of 13 is going to be 6.5. So this is going to be r times 6.5 squared. And the area, in terms of pi, what is that? 37.25? No, I'm just making that up. What is it? Oh, well, I was way off. 42.25 pi, that would be our exact answer, feet. Okay, and then our estimated answer or approximation is, Eric, what do you get there when you do that?
132.73.
We agree with Eric there? Feet. Did I put a label up here? I did not. What's my label? Centimeters. Did I use the right label here? Oh yeah, this better be square feet or feet squared. Okay, anytime you're finding area, it needs to be squared. If you're finding the diameter like we did on the second one, the diameter is not area, so we can just call that a linear measure. We don't need squared. Okay, last one here says find the radius if our area equals 36 pi. So area equals pi r squared. And if our area is 36 pi, I'm going to plug 36, or excuse me, yeah, 63 in for the area. So 63 pi equals pi r squared. All right, I need to solve for r. I'm going to divide both sides by pi. What happens to our pi's here? They cancel. I want you guys to understand this. If this was just 63 equals pi r squared, well then we would divide both sides by pi. It would actually have to calculate that out. But since this is in terms of pi, this is an exact answer for the area, now our pi's will just cancel. So now I'm left with r squared equals 63, and then we can square root both sides. My radius is going to equal the square root of 63, 7.94 meters squared. No, meters, right? Just meters, because this is a radius. It's a linear measure, not an area. Who's got questions for me? Next part of this is called population density. Population density is just the measure of how many people live in a given area. Okay, so this doesn't necessarily have to deal with circles, but a lot of times they draw maybe a circle around, let's just say Chicago. If I want to find the population density of Chicago, more than likely we would maybe use a circle to encompass that area. So it says about 430,000 people live in a 5-mile radius of a city's town's hall. Actually, it says find the population density in people per square mile. I think that's important to understand. That's what we're finding here. We're finding how many people live in 1 square mile, or how many people live in 1 square kilometer. Okay? So here's what we're going to do. We're going to take the people, or let me say population, or the number of people in a given area, and we're going to divide it by the area. So this is in people, and this is in like land area. Okay, so I know I'm going to take 430,000, and I'm going to divide that by the area that we're using here. Okay, is that 5? That's just the radius, isn't it? So of a city's town hall. So let's pretend the town's hall is here. City's town hall is here. A 5-mile radius makes a circle. 430,000 people live in that circle. Okay, so if it says 5, don't just, I mean, it says 5-mile radius, that's a circle. So I need to find the area of that circle. Well, area equals pi r squared. Our radius is 5 here, so 5 squared is 25. So the area of this circle is going to equal 25 pi. Okay, so that is the area. You can get a decimal if you want, or just put 25 pi in there. So we take our total population of the given area, 430,000 people, over the area, and that is in miles, square miles, and we can divide that. Again, guys, what do we need to remember when we plug this into our calculator? Parentheses around that. You will get the wrong answer if you don't type them in. What do you get? 5,475? 5,474.9 or 74 point something. Well, let's just round that to the nearest person since we're talking about people. I think that's 75 people. What does that mean? People. What do we find here? Okay, I think people per, I'm running out of room here. I like this a lot better to write this. People per square mile. Or I'll do this probably better. People per square mile. That tells us how dense the population is. Density meaning, hey, how many people are in a certain amount of area. That many people per square mile. Questions on that? Okay, next one's kind of similar but slightly different. It says a region with a 3-mile radius has a population density. It doesn't say population, does it? It says density of 6,195 people per square mile. This is different. Notice the subtle differences. Up above it gave us the population. Here it gives us the population density. Find the number of people who live in the region. So if I have a circle again, and our radius is 3, here's my circle. I don't know the population in there, but I know for every square mile, okay, every square mile in there, there's 6,195 people. I want to find how many square miles are in that region. So we're going to find the area. Area equals pi times my radius, which is 3, squared. Area is going to get me 9 pi. I'm actually going to multiply that out. Point two what? 27 square miles. Cam, is that my answer?
No.
What do we need to do?
You need to do x over 28.27 or 9 pi and do over 9 pi, and then equal to 9,195.
I think we're overthinking this. Every 1 square mile, there's that many people. How many square miles are in here? I just have to multiply them together. Okay, hey, if I said I'm going to give everyone in here $100, I better take, hey, the $100 times however many people are in here, right? For every 1 square mile, there's 6,195 people. I better times that by my square mileage. Just multiplying them together. $28.27, and yeah, if you guys actually have that, the actual calculation rather than the rounded, I think that's better, times 6,195. Cam, does that make sense? So in this region, 175,132 people. Is that what you guys got? Okay, so this is a good, did I round that correctly? 28.27? Yep. And what's the answer you guys got?
When you get exact, it's 175159.
5159. So this is 0.5, or is it 0.4?
It's 0.49.
0.49. Okay, if it's people, I'm just going to round to the nearest person, so I'll keep it at that. Wow, that's a big difference, isn't it? I'm always talking about don't round until you absolutely have to, because this is the reason why. I rounded in my calculation and used 28.27, and I'm off how many people?
17.
That's 17. Now, in the grand scheme of things, of 175,000 people, that's not that much, but it's a little bit. Okay? And I just think mathematicians should pride themselves on being as accurate as possible. Questions on population density? Okay, top of the next page. Guys, just like we found circumference and then we found arc length, we're going to find area and then the area of a sector. Now, a sector is essentially a piece of the pie. It's a part of the area of the circle. All right? So if I look here, I guess the sector is a region between 2 radii and an arc of a circle. Okay, so in my picture here, for example, we can find there'd be, I guess, 2 sectors in this particular circle. One of the sectors is the red piece, the red part of the pizza, the red part of the pie, and then the other one would be the blue one. Okay, now our formula is very similar to arc length. It's theta over 360. The part of the circle we're talking about over 360 equals the sector area, I'm calling that S, over the total area of the circle, I'm calling that A. So maybe you want to put sector there and area there. Or sector area, the area of the sector over the area of the circle. Okay, so here it says, find the areas of the sectors. So again, I think there's 2 pieces here. There's the red part and the blue part. So if I find the red part first, well, what's my, our theta there? 70. So I'm going to do 70 over 360 equals the area of the sector, which I'm trying to find, over the area of the circle. Is that 8? Is that 8 pi? 16 pi. It's 64 pi. So I need to find the area, which is pi times the radius, which is 8 squared. 8 squared is 64 pi. So the area of the circle is 64 pi. Again, set up a proportion. Here's my missing value. Go across from it, multiply diagonally, hit enter, divide horizontally. Did you even get an answer there?
Yeah.
39 point what?
1.
Just 1?
It's
1 0. Oh, it's 0.9? We'll call it 1. I like that. 39.1. Again, it's still area. Do we have a label? We do. We're going to call that square inches. So that's the area of the red piece of the pizza. Any questions about that? Now, to find the other part, the blue part, we need that angle. We need that theta. We don't want to use 70 anymore because 70 is talking about the red piece. How much is that blue piece? 200? Oh, 290. Yeah, the whole thing's 360, so it's just minus 70. So we're going to have 290, well, that's our theta, over 360, equals our sector area over our total area of our circle, which again is 64 pi. Which one's going to be more, the red answer or the blue answer? Blue, right? Plug that in for me. $290 times 64 pi. Hit enter, divide by 360. What do we get?
161.7
Square inches. How we doing there? Okay, a few more here and I get you half hour to work. Ooh, I lied. I got a few good ones at the bottom. Let's see here. I'm not going to do this one. Let's skip that one. Is that okay with you guys? Yeah, I figured it would be. Here it says find the area of circle V. So this changes a little bit. What do we know? Do I know the radius? I don't, do I? I guess if I knew the radius, I'd be able to find the area. So I don't know that. I know my theta, and I know my area of the sector. So here it's going to be theta over 360, which should be 40. 40 over 360 equals 35 over the area of the circle, which I'm just going to put A there. I don't need to put pi r squared there because I don't want the radius. I want the area. Cross multiply that thing. Chris, get an answer back there?
Yeah, 315.
Even? Even? Meters squared. Okay, now moving to the bottom. Finding irregular areas, okay? So if I look at this guy, I need to find the area of the shaded region. Okay, now I want to break this up for a second. I want to look at just this part of the circle. That part and in. You guys following me? I don't want anything outside of that red circle. I'm just focusing on that part and in. Okay, now if I were to draw this separately, I think there's two circles here. Would you guys agree? I've got the outer, I have an outer circle and I have an inner circle. I'm trying to find that. That looks like a donut. Kind of got hungry. I'm trying to find that shaded area. All right? Here's how I want you to think about it. I want you to think about finding the area of the big circle. Okay? The area of all of this, which is pi r squared, right? So I'm going to say area equals pi times r squared minus the area of the circle that's not shaded, which is that circle. So minus pi r squared. Okay, so to find the area of, essentially guys, this is what we call a ring. To find the area of a ring, you take pi r squared minus pi r squared. Now to differentiate from this, I'm going to call this capital R to let us know that that's going to be our bigger radius. Okay? We want to take the area of the big circle minus the area of the little circle. So it says every one of these little marks is 5 meters. Okay? So what's the area, if I look just at the red circle here, what's that, or excuse me, what's the radius? Morgan, what's the radius there? Of the red one that I've outlined?
Does it go shaded all the way in?
It's kind of, no. This is white, and this is white. Every one of these is 5. Isn't that 5? And that's 5. And that's 5. What's my radius? 15. So if I want to find the radius of that big circle, that's going to be pi times 15 squared. Minus, what's the area of my small circle? I think it's 10, because this whole thing, it's 10. So minus pi times 10 squared. Okay. 15 squared, I think that's 225 pi. Minus 10 squared is 100 pi. So the area of this ring, the first shaded part, well, 225 pi minus 100 pi is going to be 115 pi. Guys, that's this ring. That's the area of just this ring and this ring alone. Say it again? Oh, yeah. 125. Thank you. I don't know where I got 115 from. Are there questions there? We got to do the whole thing again. Okay? So if I look at the big circle, I need to find this outer ring. What's the radius of my big circle? What's my area? What's my radius there, Jaden?
5.
Of the big circle.
Big circle. 30.
We agree? 30 there?
Or no, it's 25.
5, 10, 15, 20, 25. So this is going to be pi times my big radius, which is 25 squared, minus. Now, my little circle is going to be this. I've already found the area of this, guys, so I'm not worried about it. I'm going to take all of this away. I'm going to get rid of all of that. So what's my radius of that circle? I think it's 20. Okay, going from the center, it's 5, 10, 15, 20 to there. So minus pi times 20 squared. Okay, again, 25 squared, that's going to be 625 pi. Minus 20 squared is 400 pi. I think this is going to get me 225 pi. So what's my final answer going to be? Well, this is the area of the smaller ring. This is the area of the bigger ring. We better add them together. I think that gives me 350 pi. Do we have a label? Meters. I do. Square meters. That would be our exact answer. If you wanted a decimal, multiply 350 times pi. Guys, there's one just like that in our homework. I have one more because there's one like this in our homework. How are we going to go about this guy? The middle one. Yep, the middle one. Turn to the person next to you. Talk about some ideas. What can we do? Go.
We could do
Ideas here. What do we got? Joe, what do you think?
We could do the entire thing minus the little circle and then divide by 2.
Say it again.
Never mind.
What? I think you're right. Keep going.
The whole circle minus the little one divided by 2.
Okay, so if you take, kind of like we do with the ring, okay? This is essentially a ring. Find the area of the entire circle, okay? And this might better understand this guy. To find the area of the entire circle, the entire thing, even that. But then we have to subtract out or minus the part that's not shaded, which is the smaller circle. That's where we get that formula. And then what do we need to do with that answer, Joe? Divided by 2. I heard someone say, could you use the area of a sector? Because I think this is kind of sector-ish. You could. I think this, since this is just a half circle, I think it's better just to divide it by 2. Okay? So we're going to take the area, and let's just find the area of the whole entire ring. And that is pi times big R squared minus pi times little r squared. Our big radius is what? 14. So this is going to be pi times 14 squared minus the little circle, the little radius, which is 7. So this is going to give me 196 pi minus 49 pi. 147 pi. What did we just find there? Alex, what did we find? What's that number mean?
That's the outside, the outside.
That's the area of this whole entire ring, the outside. What do we need to do with that number, Serena? What'd you say? Am I finding this whole ring? I'm only finding half it, aren't I, Carson? I'm only finding that part of the ring. So divide that thing by 2. What's 147 divided by 2? 73.5? Yeah. So 73.5 pi square feet. If you want an exact answer, let's find that. Take 73.5 times pi. 220 what? 230.9
9
square feet.